You know, usually when we think about a major corporate heist, we picture this classic cinematic setup. Someone is like breaking into a vault or stealing a hard drive full of encrypted source code or maybe copying proprietary blueprints.
Right, because historically that was really the only way to steal the value.
Yeah.
You had to physically or digitally extract the underlying mechanics of how something was built if you wanted to replicate it.
But, I mean, imagine a heist that wasn't about stealing the blueprints at all. What if the thieves just sat down with the master architect, bought them a cup of coffee, and just talked to them for hours and hours until they could perfectly replicate the way the architect's mind works?
It definitely sounds like science fiction.
It really does.
Mm.
But this is exactly what is happening at the bleeding edge of the tech industry right now. So whether you are prepping for a boardroom meeting or you are just insanely curious, you are the learner we build these deep dives for. And today, we are exploring a core mystery. What happens when a company doesn't steal a rival's code, but instead, they steal exactly what their artificial intelligence knows?
Yeah, and to map this out, we are relying on a deeply researched piece from Tech Reader magazine. It was written by Aaron Rose and published on June 25, 2026. The piece is titled Inside the Model Distillation Attack on Claude.
It is a fantastic read.
It really is. And our mission today is to pull this reporting apart. We need to understand how the largest known extraction attack in history was carried out against Anthropic's flagship AI model, Claude.
Because it is a huge deal.
Exactly. We are going to examine the mechanical reality of cloning an AI's behavior and really look at why this specific event fundamentally shifts the entire global tech race.
Okay, let's unpack this.
Yeah.
Because we need to be crystal clear right off the bat, right? This was not a traditional hacking event.
No, not at all.
Nobody smashed through a firewall or bypassed a server's encryption.
Yeah, to set the stage properly, you really have to look at this as a highly coordinated 6-week operation. The attackers essentially reverse-engineered a frontier AI model using 28.8 million targeted conversations.
28.8 million. That is just a wild number.
It's massive, and they used a method that actually borrows heavily from legitimate machine learning research. But, the intent here was totally weaponized extraction.
Okay, so let's move from that broad concept to the concrete details that just broke open publicly. The Tech Reader article really centers on a letter Anthropic sent on June 10, 2026, to Senate Banking Committee Chair Tim Scott and Ranking Member Elizabeth Warren.
Right.
And this was initially reported by Bloomberg and then heavily corroborated by Reuters, CNBC, and the Wall Street Journal. So who exactly is Anthropic pointing the finger at here?
Well, the accusation in that letter is highly specific, and frankly, it's explosive. Anthropic formally accused operators affiliated with Alibaba, specifically its AI research division, Alibaba Quinn. They accused them of conducting this massive campaign, and the timeline they laid out is staggering. The operation ran from April 22 to June 5 of 2026.
I mean, that is 44 days of nonstop extraction.
Exactly, generating those 28.8 million exchanges we mentioned earlier.
And the scale required to do that is what really catches my attention. Like, the reporting states they used nearly 25,000 fraudulent accounts.
Yeah, 25,000.
But they weren't just pinging the AI with basic trivia, right? Or asking you to write polite emails. They were targeting Claude's absolute most advanced capabilities. The article mentions agentic reasoning and long-horizon task completion.
Right, which are huge buzzwords right now.
Yeah, so break those terms down for us, because that sounds a lot more complex than just a standard chatbot.
Yeah, so those are what we call frontier capabilities. They are the most expensive and computationally heavy things an AI can do.
Okay.
So agentic reasoning basically means the AI isn't just answering a single question. It is acting like an autonomous agent.
Like it has agency.
Exactly. If you tell it, build a functioning e-commerce website and deploy it, the AI has to plan out a dozen distinct steps. It has to recognize its own errors, rewrite code, and execute the entire project without you holding its hand.
Oh, wow. Okay.
And then long horizon task completion is similar. It's the ability to hold a complex goal in its memory over a long period and work toward it systematically.
Right.
So these are the specific, highly valuable skills the attackers wanted to clone.
To put that in perspective, it feels like sending 25,000 fake customers into a Michelin star restaurant.
Yeah, that's a good way to look at it.
And none of them actually want to eat the food. They just want to sit at the chef's table and ask highly specific, mathematically calculated questions. Like, They ask about the exact temperature of the oven, the precise acidity of the tomatoes, and the timing of the reduction sauce,
Right, exactly.
until they can literally walk across the street and recreate the signature recipe without ever stepping foot inside the kitchen.
That analogy captures the intent perfectly. They are extracting the recipe entirely through conversation.
But wait, I have a major pushback on the logistics of this.
Okay, lay it on me.
If you send 25,000 fake customers into a restaurant, the manager's going to notice immediately.
Yeah, I would think so, yeah.
So how does a sophisticated tech company like Anthropic not see 25,000 fake accounts hammering their systems with highly complex coding questions? Wouldn't internal alarms be going off everywhere?
Well, that brings us to the most sophisticated part of the heist, which is the access layer. So Anthropic utilizes something called rate-limiting logic.
Rate limiting.
Yeah. Think of it like a bouncer at a club who counts how many drinks you've had. If one account asks 1,000 complex questions in a minute, the bouncer cuts them off.
Right, that makes sense.
And if 25,000 brand new accounts suddenly logged on from the exact same location and started aggressively querying software architecture, Anthropic's anomaly detection would ban them in a heartbeat.
So how on earth did they bypass the bouncer?
By blending in perfectly. These accounts were designed with plausible profiles and, more importantly, plausible usage histories. Oh, wow. So they looked like real established users.
Exactly. They exhibited a pattern of queries that was engineered specifically to stay just under that rate-limiting threshold.
Sneaky.
And furthermore, the volume was widely distributed across different IP addresses and time zones. You might have a few hundred of these accounts active at any given hour, rotating in and out, simulating human typing delays.
That is insane.
They basically masked a systematic industrial-scale extraction operation inside a sea of what looked like heavy but normal user traffic.
They essentially hid the greatest heist in tech history in plain sight. Which means we really need to dig into the actual mechanics of this extraction. Like, how do 28.8 million text conversations actually equal a cloned artificial intelligence?
And this is where we have to look at the specific technique they used, which is called knowledge distillation.
Okay, and here's where it gets really interesting. Because knowledge distillation isn't some new evil hacking tool invented on the dark web last week.
No, not at all. The Tech Reader article points out that it was formalized by researchers around 2015 for something totally benign called model compression.
Yes. The original problem the tech industry was trying to solve a decade ago was computational cost.
Right.
Large AI models are incredibly expensive, and they are slow to run. So researchers theorized that if you could train a smaller, cheaper model to act like a larger one, you could run it on a smartphone instead of a massive server farm.
So the basic setup relies on a large teacher model and a smaller student model, right?
Precisely.
You feed complex inputs into the teacher, you meticulously record what the teacher spits out, and then you use those exact input-output pairs to train the student. So the student isn't learning from reading the whole internet anymore.
No, it skips all that.
It's learning entirely from how the teacher responds to data.
Right. The mechanism is what is crucial here. In traditional AI training, a model learns the underlying structure of language by reading trillions of words.
Yeah, that takes months.
But in distillation, the student model is essentially using the teacher's outputs as a highly refined training signal.
I like to think of it like tracing a masterpiece painting.
Right.
Like, if I want to recreate the Mona Lisa, I don't necessarily need to know how Leonardo da Vinci mixed his pigments, you know?
Right.
I don't need his deep understanding of the physics of light or human anatomy or the chemical composition of the canvas. I just need enough tracing paper to mimic his exact brush strokes.
Exactly.
Because if I trace enough of his work, I can produce something that looks awfully similar to a Da Vinci without possessing a fraction of his actual genius.
Let's expand on that tracing analogy, actually, because it translates perfectly to the neural network level. In the AI world, Da Vinci's deep understanding of anatomy and light represents the model's underlying weights.
What new weights?
Yeah, the billions of mathematical parameters that took months and millions of dollars of compute power to calculate.
Right, the core brain.
Right. So for a distillation attack, the attacker doesn't need to break into the server to steal those underlying weights. They just need API access and enough tracing paper. And the tracing paper in this case is a massive volume of highly structured queries.
Structured queries. Yeah, the article makes a very clear distinction between this kind of structured distillation attack and just ordinary API abuse.
Yes, there is a big difference.
Because if I'm just scraping in AI's outputs to publish cheap articles on a spam website, that is certainly abuse. but it isn't cloning.
No, ordinary abuse is about using the output as an end product. A distillation attack uses the output as a mechanism to fundamentally alter the neural pathways of the student model.
Oh, that's fascinating.
And generating random outputs doesn't work, by the way, it just adds noise.
Right.
To effectively trace the master, the attackers had to ask the exact right question in a very specific sequence to capture the nuance of how Claude reasons through a problem.
Because they are trying to map the logic.
Exactly. They needed to systematically map how the AI hedges when it is uncertain, how it structures complex coding answers, and how it breaks down that long horizon task into smaller steps.
Wait, I'm stuck on something here. Let me question the premise of this entire panic.
Go for it.
If tracing the masterpiece is just capturing the surface brushstrokes, and it doesn't give the student model that deep underlying mathematical understanding, doesn't the student model eventually hit a wall? Like, do they actually steal the entire AI?
Well, what's fascinating here is no, they didn't scale the entire depth of the AI, and honestly, they didn't need to.
Okay, wait, explain that.
You have correctly identified the ceiling of distillation theft. Distillation captures surface behavior brilliantly, but the student model does not acquire genuine, generalized capability.
So what happens when you ask it to do something it wasn't specifically trained on during the extraction?
It plateaus. It degrades. Because deep generalization comes from training on vast, raw data sets using enormous computational power. You cannot perfectly transfer that deep underlying understanding just through a behavioral interface.
All right, that makes sense.
So the student model will perform incredibly well on tasks that look exactly like the coding queries it was fed during the heist. But the moment you ask it to pivot and do something requiring genuine, novel generalization outside that extracted data set, it hesitates. It fails.
Then why is Anthropic so incredibly worried? Why is this a massive geopolitical incident?
Yeah, it seems counterintuitive.
If the student model plateaus, and it fundamentally lacks the deep reasoning of Claude, aren't the attackers ultimately just left with a cheap, brittle knockoff? Like, who cares if someone builds a worse version of your product?
Because of the brutal economics of the artificial intelligence industry. Let's look at the financial asymmetry here.
Yeah.
Let's say Alibaba Quinn extracts enough data to build a student model that performs at 90% of Claude's capability on a few highly specific, commercially relevant tasks, like software engineering.
Okay, so it codes at 90% proficiency.
Yes. And they achieved that 90% proficiency at a microscopic fraction of the development cost.
Oh, I see.
They didn't have to spend years experimenting. They didn't have to spend $1 billion building a massive data center. For many commercial applications, an AI that is 90% as good as the frontier model is perfectly adequate.
Right, because most businesses don't need a supercomputer. They just need something that works pretty well.
Exactly. In fierce business competition, 90% at 1/10 the cost is a winning formula. The attacker basically skips the entire mountain climb and just lands a helicopter right on the plateau.
Wow, that completely flips the perspective. They get all the commercial value without the foundational investment.
Exactly.
But if Anthropic understands exactly how this works, why not just build a digital fence? Surely these labs have security measures to block this kind of automated extraction.
Well, they absolutely do have defensive measures, but the tech-reader article details just how difficult this is to police. We already discussed rate limiting and behavioral anomaly detection, which are the first lines of defense. But beyond that, companies try to use output filtering and watermarking.
Now, output filtering sounds self-explanatory. You just stop the AI from giving answers that look like they're being used for training.
Right.
But how does watermarking actually work in a text conversation?
Yeah.
You can't put a translucent logo over a paragraph of code.
Yeah, text watermarking is a fascinating, though currently experimental, mechanism. It works by subtly tweaking the probability of the AI's word choices.
The probability.
Yeah, so every time an AI generates a word, it is selecting from a list of probabilities. A watermark deliberately forces the AI to choose specific, slightly less probable words in a mathematically recognizable pattern.
Oh, that is wild.
Right. To a human reader, the sentence looks perfectly normal. But if you run that text through a detection algorithm, the mathematical pattern of those specific word choices acts as an invisible cryptographic signature. It proves the text came from your model.
That is brilliant. But the article notes watermarking is still largely an active area of research, right?
Yes, exactly.
It isn't fully deployed at scale to protect these models yet, which leaves us with output filtering. And this seems like the glaring flaw in the defense.
It really is.
Because if you aggressively filter the outputs, like if you make the AI refuse to answer complex structural questions because you are terrified someone is extracting its logic, you are severely degrading the product for your actual legitimate paying users.
Yes, and the asymmetry here is just stark. The attacker's cost is basically paying API fees and setting up fake accounts.
Right.
The defender's cost is billions in compute, and the only way to fully protect their intellectual property is to intentionally break their own product.
Which is an impossible choice.
Completely. And the timeline in the Anthropic letter proves how ineffective these defenses currently are. Despite having rate limiting and anomaly detection in place, this 44-day operation ran to apparent completion before anyone managed to shut it down.
According to the reporting, this is far from an isolated incident.
No, not at all.
The article notes that earlier in the year, around February 2026, Anthropic identified major distillation campaigns by 3 other entities: DeepSeek, Moonshot, and Minimax.
And this brings a critical geopolitical layer into the conversation.
Yeah, definitely.
The Alibaba campaign aligns chronologically with something called the Fable 5 export control shutdown.
Right, Fable 5.
So for context, Fable 5 was a major policy move designed to restrict high-end, powerful computational chips from being exported to certain countries, specifically to slow down their AI development capabilities.
So if a foreign lab can't get the physical hardware to build their own massive teacher model, their next logical step is to just use American APIs to distill the knowledge into a smaller student model.
Precisely.
Yeah.
Which is why Anthropic used very deliberate language in their letter to the Senate Banking Committee.
Right, they call it a subsidy.
Exactly. They explicitly called this attack a subsidy for geopolitical competitors. They are framing this as American innovation and financial investment being siphoned off to close the global tech gap, effectively bypassing those hardware export controls entirely.
Now, we need to ensure we are presenting the full picture here and reporting exactly what the source material states from all perspectives.
Of course.
Because China's state media pushed back on this narrative immediately. The Global Times published expert commentary rapidly following Anthropic's letter.
Yes, they did.
And they stated that Anthropic's claims entirely lack substance, and they actually categorized the accusation as technology hegemony anxiety.
Right.
So we have Anthropic claiming intellectual property theft on a massive geopolitical scale, and the Global Times claiming it is an anxious overreaction by an American company desperately trying to maintain a monopoly.
Yeah, it's a very clear divide.
And to be clear to you, the learner, we are not taking a side on who is right or endorsing either viewpoint. We are simply laying out the reality of how fiercely this is being debated on the world stage based on the reporting.
And the reason that debate is so fierce is because the stakes are completely unprecedented. Regardless of whether you view it as blatant theft or just hegemony anxiety, the technical reality on the ground remains identical.
Yeah.
The capabilities of frontier models are being replicated at scale without the corresponding foundational investment.
So what does this all mean? We need to zoom out from the specific Alibaba and Anthropic conflict and look at what this means for the broader tech industry.
Okay.
Because that ceiling we talked about earlier, that plateau where the student model hesitates and stops learning, the article makes it very clear that the ceiling is not permanently fixed.
No, the ceiling is constantly moving higher. Attackers are learning from these campaigns. They are already building the next generation of extraction methods, using even more queries, infinitely better structural mapping, and targeting a much wider range of reasoning tasks to push that plateau closer and closer to the frontier.
Which means for you, the learner listening to this right now, the future of the tools you use every day is shifting beneath your feet.
Yeah, it really is.
If you are using different AI tools for work, or academic research, or software development, you might soon be looking at a total illusion of choice. You might think you're choosing between 5 wildly different competitive products, but under the hood, they might all just be distilled 90% echoes of the exact same frontier model.
If we connect this to the bigger picture, offering public API access is no longer a neutral business decision for these massive tech labs.
Wow, yeah.
Every single time a frontier model returns a high-quality, perfectly reasoned answer to a user, it is actively generating premium training data for a potential competitor.
So the very definition of having an advantage in the tech space has fundamentally changed.
It used to be that your advantage was simply building the smartest, most capable model.
Right.
Now, frontier advantage is defined entirely by your ability to maintain the behavioral gap.
The behavioral gap.
Yes, that is the gap between what your actual model can do internally and what can be extracted from it through an external conversation. And that gap is narrowing. It is narrowing 28.8 million exchanges at a time.
That is just, wow.
The real battle of the next decade isn't just about creating intelligence. It is about protecting the shape of that intelligence from being traced.
It's an incredible evolution. I mean, we have gone from a clever 2015 compression technique designed to save server costs to a 44-day, 25,000 account extraction heist that cloned an AI's reasoning capabilities and fundamentally altered the economics of global AI development.
The mechanism of theft has evolved from taking the hard drive to simply having a conversation.
Which leaves me with one final thought, something I want you to mull over and explore on your own after we wrap up today.
Yeah.
If AI behavior can be cloned this effectively just by talking to it, will we eventually reach a breaking point where frontier AI companies have to stop offering public API access entirely?
That is the big question.
If the master architect has to lock themselves in a soundproof room and stop talking to the public just to protect their own mind, what happens to all the developers, the builders, and learners like you who rely on those tools to build the future?
It fundamentally questions the viability of open technological development.
Thank you for joining us on this deep dive. Keep asking those big questions and stay curious. We will catch you next time.